So I just wanted to talk a little bit about what we did on the previous little video. The process used in the preceding example is called completing the square. Okay? And the word completing the square refers to the addition of the b squared to x squared plus 2bx to obtain the trinomial x squared plus 2bx plus b squared, which then factors by the binomial theorem with degree 2. It factors as the perfect square, right? Open paren x plus b close paren squared, or x plus b the quantity squared. So that's why it's called a perfect square. Okay. So completing the square is just adding the b squared in there so that the remaining trinomial, this thing, is a perfect square. So a perfect square is a square of an integer like 4, 9, 16, or the square of a polynomial is also called a perfect square. Okay, so this is a polynomial. It's actually a binomial, right? And it's being squared. So that's a perfect square. So as I mentioned before, the term b squared can be added and subtracted on one side of the equation, which always works. When the leading coefficient is or are 1, and we have a quadratic equation, that is, there's equal something, then we can add b squared to both sides of the equation instead of adding and subtracting b squared. That's just a different bookkeeping method. It really amounts to the same thing. But for these circles, I would probably, in most cases, just add b squared to both sides of the equation. And for the circles, there's going to be a b squared for the x terms and a b squared for the y terms, right? And so I'm going to do this next example that way. It'll be on the next video. The text uses the first method later on in the book, and it uses the second method here for circles because it's easy to use for circles, because you always have an equation.